Welcome to FunPhile. If you haven't been on this channel before, and if you have no idea what it is about, I suggest, first of all, you check out the channel, okay? And second of all, I'll just tell you a bit about it. So, FunPhile is basically all-in-one. I mean, you can pretty much get everything out of it. Like, we have cubes, we have cooking, we have books, we have book reviews, pretty much you name it and we have it. So, and we also need a lot of feedback. So, I mean, if you find anything you really want, so you can just post it in the comments and we'll see it and we'll try to feature that. Okay? So, this playlist is called Educational Fun because it's fun that's educational. So, that was a rather, so basically what we do here is we have experiments, we have problems, we have books, we have, that sort of stuff. And it's fun, it's actually fun. I'm gonna try to make it as fun as possible, so bear with me. So let's start, okay? Today we'll be doing a very simple two-dimensional motion problem. Okay, so here it goes. You are a circus manager. For your first crazy stunt, the performer must be fired from a cannon at the maximum speed of 5 meters per second. Max speed Trixie can handle. And I forgot to tell you, this is going to be in a series. It's not just one problem, so if you notice, it just says A here, okay? So at 60 degrees from a height of 10 meters, then a landing platform, a trampoline of course, who doesn't love trampolines, must be at hand to prevent her from falling to her doom. What are the distances between the launcher and basically the cannon and the trampoline? What's the distance? So we're gonna, pause the video here if you want to give it a go by yourself. So let's start. First, let's visualize this. So here's the cannon, a rather lousy drawing, I know, but it's okay. So here's the cannon. It's fired at an angle of 60 degrees, and here's Trixie jumping out of it. Here's the trampoline, and if you notice, the problem said 10 meters, and you ask me, where's the 10 meters here? Well, it really doesn't matter here, because this is 10 meters. It doesn't matter how far she has to fall. Sorry, Trixie, but okay, it doesn't really matter. So, let's start. So, this is 5 meters per second. This is 60 degrees. In these kind of problems, we often start by calculating the competence of the velocity or vector. So we start by calculating the velocity and the competence, like the horizontal and the vertical. Like how fast is it going in the vertical direction, how fast is it going in the horizontal direction, because it's going this way. So you can't really, get a clear idea how fast it's going that way and this way. So calculations get messed up if you don't divide it first. So that's why we got to do that first. Then we have to plug in the equations and it's going to get easier. Okay, so let's start. Okay, so we got to calculate the perpendicular and parallel competence of the vector. So basically, it's handy to draw a triangle like this. So if this is the vector, this is 5 meters per second, 5 m meters per second. You can draw out the one parallel to the ground and the one perpendicular to the ground, right? Okay. Now, we got that. Now, how are we going to solve for, okay, we forgot one minor detail. This is always going to be 60 degrees. Okay, so here we gotta use basic trig functions. Trig functions like sine, cosine, tangent. Okay, so if you're not familiar with that, I'll just give you a basic overview. Trig functions are basically a ratio between the sides of a triangle. It's a basic, like for example, sine, it is going to be opposite of the angle over the hypotenuse of the triangle. This is valid for 90 degrees, and like I said, this is perpendicular to the ground, so we know this is 90 degrees. So opposite over hypotenuse. And we got a very famous sort of mnemonic for this. It's SOHCAHTOA. You got to have heard of this at one point. So I'll just erase this out. Okay, now let's continue. So using that, sine of 60. You'll get this in your formulas most of the time, but it's handy to think about, especially if this is your first time, how is this actually working? Sine of 60, opposite over hypotenuse. So opposite, I like to call them x and y because of the y, the vertical velocity, and that's the horizontal velocity, so that's x. So sine 60 is going to be equal to opposite, which is y, over hypotenuse, which is 5 meters per second. I'm just ignoring it here. Okay, I'll just put it here. So y is going to be, with a bit of simple algebra, 5 meters per second times the sine of 60, right? Okay. Same thing if you do it with x with cosine, if you do because adjacent over hypotenuse. So you get x is going to be equal to adjacent, x is going to be equal to 5 meters per second times the cosine of 60. Because if you notice, cosine is going to make ka, adjacent over hypotenuse. Cosine of 60. So if you just solve for this, you get, okay, so 5 times sine 60 is square root of 3 by 2. So square root 3 square root times 5 equals over 2. You get approximately 4.33. About 4.33. About 4.33. Okay? And if you do the same thing with x, cosine of 60 is 1/2. So 5 by 2 is 2.5, right? So that's going to be 2.5. Okay, we got that. Now, that's in meters per second if you notice. Meters per second. Because this is 5 meters per second, so that's also going to be in meters per second. So just write that down, and then we'll erase the rest. Alright? Okay, now we got that clear. Okay, here's a neat thing. Okay, so when you have something flying in the air in a parabolic trajectory, basically like a parabola, like that way. When you go that way, at the very top, at the maximum height of the parabola, when the object reaches the maximum height of the parabola, it always has a velocity. It always has a velocity of 0. Okay, at that very moment, at that precise moment, it has a velocity of 0. Okay, so that's basically something to remember there. Okay, so that's always going to be in the middle of the parabola. Although I didn't draw it very well. Middle as in the vertex, right? Vertex. So it's going to be. So with that in mind, we can use this formula. V final is going to be the V initial plus A as in the acceleration delta t. Now what we're going to do is, since we don't know the acceleration in the x direction, we're going to use only the y direction. So you can just put in the y there. Just going to put in the y there. Right? So we're basically doing this to calculate the time, right? The time it took for it to go from here to here. In this case, 60. So that's going to be, we use the y component, right? So what's the final velocity in the y direction? We just found it here, right? It's always going to be 0. 0 is equal to, what's the initial velocity? Well, this thing, right? It's an initial velocity in the y direction. It's 4.33, right? Plus A, the acceleration is going to be downwards, because what's the force of gravity? The force of gravity is applying the force downwards with an acceleration of 9.8 approximately. We're going to take that as approximation times the change in time, right? So if you solve, you get 9.8 delta t is equal to negative 4.33. Okay, over 9.8 is going to be 4.33 divided by 9.8 equals, it equals approximately half a second. Okay, it was approximately half a second, negative half a second, but time doesn't apply to, half a second. Okay, now, sorry, 5. Yeah, so that's going to be 0.5 seconds, right? So it went half the way in 0.5 seconds. How long will it take for the entire thing? Well, obviously, 1 second. Okay, we got the time. Now, all we have left to do is use this formula. The displacement in the x direction, if you remember the formula, it's going to be v initial times the time plus at squared over 2. I forgot the delta there. It's okay. T squared over 2 equals, here's the v initial is gonna be in the x direction. So the v initial in the x direction is this: 2.5 meters per second. 2.5 meters per second times the 0.5 seconds plus at squared. What's the acceleration? The acceleration in the x direction is going to be, okay, when it's getting pushed that way, does is there any acceleration in the x direction? Is there any force acting in the x direction? The answer is no. So this simplifies off to 0. What's 2.5 times 0.5? Okay. 2.5 divided by times 0.5 equals approximately, not approximately, 1.25. So that's going to be the answer, 1.25 meters. That's how far Trixie needs to go. Got it? If you got that answer, give us a thumbs up. Okay? So clear all the drawings. Okay, so let's go. Let's move on. So stay tuned for the next part where on your very own surface, Trixie will perform yet another trick on trampoline. Until then, next time, bye! Thanks for watching. Don't forget to subscribe for more fun videos like this one.